Welcome to a new episode on the Technomura channel. We really hope you will enjoy watching it and invite you to tell us what you think of it by leaving your reactions below the video. And now, please allow me to present your host, Technomura.
Thank you, Julie, for your very nice introduction. Today, my dear channel viewers, I'm going to start a new project, and I'm going to go a little bit out of my comfort zone, and I'm going to repair and refurbish a Sony TC-144 CS cassette recorder amplifier. Cassette players are notorious for being very difficult to repair if something is broken. They are full of proprietary mechanical parts, and if those are broken, they are extremely hard to repair or to replace. Yeah? Spare parts for these are very rare and in between indeed. Alright, so this is the back of the TC-144 CS, and as you can tell, there's a phono input, alright, which can be connected to a classical record player. Alright, there's a line in which can be considered as a auxiliary input if you wish. There's also a DIN input output, which can be used to connect a tape recorder or another cassette player, or even a tuner if you would wish so, right at the back. Then there is a line output which can be used to connect to another amplifier. Alright, and then we have the speaker output, because like I told you, this cassette player recorder has a built-in amplifier, stereo amplifier, and as it indicates, you should connect it to 8 ohm speakers right here. And then there is the AC power selector. I live in an area where historically equipment used 220 volts, but not too long ago, say 10 years or so ago, we were upgraded to a 240 volts line instead. So I will in time set this selector to 240 instead of 220. So the first thing that you notice is this rather hefty transformer right here. We don't know yet if the transformer is okay, but we'll measure it in a moment. It does seem to have several primary windings and 2 secondary windings, which would be logical for a stereo amplifier. Then you have a central board right here, which I suspect is full of filters and such. Yeah, and then you have the mechanical part, the dreaded mechanical part of the cassette player. Alright, I suspect that to get better access to the inner mechanism of the recorder, I will need to release the wooden bezel around it. Yeah, and as you can tell, there are some feet, protective feet mounted to the bezel, top and bottom. But I don't need to really unscrew those, because if you look closely, those protective feet are really attached to the wooden bezel, but nothing else. However, the carrying strap is connected via two big screws to the rest of the mechanism via this bracket here. So I suspect the only thing I need to release to be able to lift off the wooden bezel is the carrying strap. It turns out there is a third screw at the other side that I need to unscrew first. So let me take care of that. On top of the cassette player there's this nifty little box in which the DJ could place up to 3 cassettes. Alright, so, and it has this rather cool looking smoked plastic cover. What I'm looking for right now is how to lift up the plastic bezel on top without breaking it. To release the bezel, the top cover, let's say, of the recorder player, you also need to take off the buttons of the slide controls, alright? And that's simply done by gently lifting it like this. Voila, like that. Alright, so here's the first proof that somebody tried to, I would say, break into the recorder. And right down there, where I'm shining the light, there is a screw indeed holding the bezel to the plastic top, in fact, of the recorder to the chassis. And that screw, as you can tell, is completely ruined. So somebody tried to use excessive force to get into the recorder. Alright, the treacherous little screw, which is still holding down the top cover of the recorder, is hidden down there. Alright, so the top is loose, so now let's lift it off and have a look underneath, shall we? It should come off. There you go. And that's the underside of the top cover. Very tricky to release. Very, very tricky. Now, another proof, let's say, of the quality of this recorder is that, you see, this has an aluminum front part, okay, and Sony even took pains to ground that aluminum cover. You see that with that copper spring which connects to the chassis? And they even did it for the little box which contains the cassettes. Yeah. So, like I said, typical quality you would expect from Sony. You know, the cassette player itself and the electronic part, you know, with the filters and such. For the cassette player. Very, very nifty. Very compact as well, you know. And the little VU meters, yeah, which will also need some cleaning. And you know what's typical, the paint splatters you find on all this kind of equipment. So something tells me that this must have been used in the past in a room where they were, let's say, painting. To get to the filter board, which is hidden under here, I needed to release 2 screws on top, and I also unfortunately need to release these jacks. And to do just that, I'm using a nifty little ratchet, which I have, and which fits right over the nuts which hold down the jacks. Alright, so like this, and then you just gently twist it down and off it comes. You know, if at all, don't use pliers to do this, or you'll cause to have a lot of scratches on everything. Alright, I had in the end to release this little bridge piece here, which was attached with these 4 screws to the row of switches on top, in order to slide out this board. Alright, which makes my life a little bit easier to work on the amplifier board and of course on the filter board itself. The filter board only has 2 electrolytics down there in the corner which need replacing, but it also needs a bit of cleaning, and the switches need a bit of cleaning too. So in the end it turns out to be quite handy to release them. Obviously the hardest board to recap is the amplifier board. Alright, to release the jacks from the chassis, I used this nifty little box of socket wrenches, you know, and that's the word I was looking for. This is called a socket wrench, and I have a whole collection of small socket wrenches which I can use either in combination with these or with my electrical screwdriver. Alright, so I unsoldered the first capacitor from the amplification board, and it's a 10 volts 470 microfarad, and there seems to be a date code on top, and if I interpret this correctly, this should be from June 67, which would make this capacitor 54 years old. So yeah, I think this capacitor has been long overdue for replacement, although the values measure, let's say, relatively normal. For the capacitor of this age, for a capacitor of this age, the values are relatively normal, although it does measure about, I would say, 15% over the rated value. Either way, these things are chemical and they degrade as they age, and since we've established that this capacitor is probably 54 years old, I think it's still well, good practice to replace them. The engineers at Sony were so nice to provide for a little symbol on the PCB which shows you where the anode and where the cathode, or the plus and the negative of the capacitor should be connected. And you see that little symbol where I'm holding my thumb, so the little U-shaped symbol on top indicates the negative, whereas the little horizontal bar you see below it indicates the positive. And as you probably all know, you should install electrolytics in the right direction on a PCB, okay? So plus to plus, negative to negative. Never reverse the polarity on a capacitor, an electrolytic capacitor, because if you do and you switch the thing on, it might go pop, or if you're unlucky, it might even go bang. Okay, I heard you. So how do you check the polarity on an electrolytic? Well, generally an electrolytic has, you see, a stripe of minus symbols indicating its negative pin, and of course the other pin then conversely is the positive one. Okay, so I'm saying generally because some electrolytics have the reverse, so the positive pin is marked with little pluses instead of the negative pin with little minuses. Okay, but another way to identify which pin is positive and which is negative, the positive pin on a brand new capacitor, on a brand new electrolytic capacitor, is always, or well, most of the time, longer than the pin indicating the negative. So take a good look at this 5.6 kilo ohm resistor. I mean, the poor thing had a broken pin on one end, as you can tell, and the other pin was barely soldered on. Yeah, so it just fell out of the main board. So this board, in fact, here, all right, the amplification board, you could say. And this is a resistor of one of the two channels, and yeah, it just fell out, just like that. So, in my opinion, the sound quality of the cassette deck is probably never been too good because of this, of course, but not only because of this, but also because of these. So these are all the electrolytic capacitors that were in the cassette deck, and I replaced them all. Yeah, not one is, or rather all of them are new. Yeah, some of these capacitors were seriously out of value. Some even as much as 50% over value, and all of them, or practically all of them, are seriously leaky. And by leaky I mean electrically leaky. Okay. So there are 33 of those electrolytics, and it took me some time to get them all replaced, but now all the print boards are sporting new electrolytic capacitors, just like, for example, the speed regulator board for the cassette deck motor, which you see over there. So yeah, it took me quite some time to do it, and I had to do it very carefully because, as you can tell, the cassette deck is really full, but chock full of wiring. So if you're not careful, you're going to burn all the wiring. If you're going to release glue residues off of any surface, especially metal or plastic surfaces, and you don't want to damage anything, I mean, you could use acetone, for example, to release glue, but acetone on plastic is a no-no. Okay, if you're going to use acetone on plastic, you might as well throw the object away. Acetone will dissolve plastic. But if you want to do it gently but effectively, use petrol, cleaning petrol. Okay, so what you do is you soak the spots where glue was stuck to. You let it soak for, say, a minute or so, maybe even 2 minutes, and then with a paper rag you just wipe it away. And if it doesn't work immediately, if you don't manage to take it all off in one go, then just soak it again with petrol and then wipe it off again. And you'll see, petrol works best with most glues. Okay, strangely enough, it was really simple to unmount the bracket which is keeping the flywheel in place. And it would seem that the top of the flywheel is a little ball bearing, and the seat of the ball bearing is a kind of, I would say plastic, maybe bakelite, I don't know, but it looks something like plastic. And there was apparently some measure of grease on it, but the grease doesn't look very healthy. So I'm going to clean these two parts here, so the ball bearing and the plate and the flywheel, and I'm going to replace the belt and then re-grease the ball bearing for future use. I'm going to use just a little bit of lithium grease to lubricate the top of the flywheel. Yeah? And when I say a little bit, I really mean just a touch of lithium grease. Okay, so give me a moment and I'll show you exactly what I mean. Just a touch of lithium grease like this, and then I put it on the ball bearing. Alright, like that. You know, no need to go overboard. Just a little bit of lithium grease will do. Alright, and then I'll do the same thing on the seat of the ball bearing, which is that, you remember that little plastic bit. Alright, so like this. There you go. Right? No more than this. Okay, so like I said, there's no need to go overboard with the greasing. The rewind button of the cassette deck is not working, and after long and hard thinking, I decided that to find actually the possible source of the problem would be to jump into the rabbit hole and unmount the mechanical part of the cassette deck. I discovered a few more little errors, by the way, or faults that I should take care of, but the rewind button of the cassette deck mechanism is the biggest problem I have. Right now at least. So I unmounted the belts, I unsoldered the cables going or running to the play head and the record head. I also unsoldered the wires going to this little switch here. I'm still unsure what this switch actually does, but I unsoldered it anyway. The only wires I left intact are the ones for the motor, because obviously at one stage I will have to test out the mechanism. So, like I said, I unmounted the flywheel and the drive belts to have a closer look at the underside of the mechanism. And I have to confess, I'm not an expert on mechanical stuff. So, right now I'm struggling a little bit to find the possible source of the problem. In the meantime, of course, I take the time to clean a few parts, since, well, I have the opportunity to get into the insides of the cassette deck. But yes, it'll take me a little while to figure out what is wrong with the playback or rewind button rather. Alright, I think I may have found the at least part of the problem. So let me take a pointer and I'll show you what I mean. So the reverse should be powered, yeah, by this little white wheel here, which is the drive wheel, either for the fast forward or the rewind. And as you can tell by the fast forward, with the fast forward wheel, or the play position rather, this little drive wheel makes contact with this wheel here. Now, if you have a closer look at the rewind is driven by this little rubber wheel here. And this wheel should be able to move over here to be rolled back by this little rubber wheel here. Now, to do that, the drive wheel should pivot to the other position, alright? And it does that by pivoting around this axle right here. And that axle is held in by a clips washer. You see it like that, you know, a little clip washer. And it pivots, if you look at the underside of the mechanism. Hang on. So it actually, let me see, yes, it pivots around this point here. Alright, so around this little lever here. Now, I tried to move it a little bit with my fingers, you know, because I don't really want to force the mechanism. But this little lever here seems to be frozen solid. So there is something wrong in here. So there is a problem right in here. So what I'll probably need to do is unmount the clips washer on the other side of this axle, and then see if I can lift out this part here of the mechanism and see if there's something wrong with the axle which goes into this lever. Now we are really down the rabbit hole. So I unmounted the little lever you see here by unclipping 3 springs and unscrewing it, you know, unscrewing one screw which is held here, and unmounting a little metal lever. Alright, so I really don't like this sort of stuff. This is the situation where you end up finishing with a few extra screws and a whole bunch of washers which you don't know where they fit. Yeah. So yeah, I even managed, imagine that, I even managed to undo the little clips washer which was at the top of this little axle here, without it flying away. You know, which is great, because these little clips washers are, I wouldn't say they are irreplaceable, but they can be a pain to find. Either way, when I wrench the two parts of this lever with my fingers, it does move, but it's really very, very stiff. Now, the question is, of course, is it supposed to be that stiff, or is it supposed to move? Yeah, I can't imagine that they would fit an axle into a bearing, which this is. I think this is a friction bearing. So I can't imagine that they would hold an axle in a clamp, let's say, or in a bearing like this with a clips, but to have sort of a fixed mount. I just can't believe that. I mean, it must be possible for the little lever you see here to pivot around the larger one you see here. Alright, after cleaning the axle here with some WD-40 and then wriggling it back and forth like this for roughly half an hour, it finally started loosening up, and I sprayed it several times with WD-40 until it became so loose and that it actually moves very easily back and forth now. There's a little bit of friction, I can feel that, but it's really, well, compared to what it was before, it's really nothing. Yeah, the friction is practically gone. And then I dripped the tiniest of drips of silicone oil right in here. Alright, the lever is back in place, and all the little springs are back into the position they should be. This metal lever is also back. If you release this lever, or if you put it back, you need to be very careful not to break this little plastic tab here. Okay, it's a little bit bendy, so you can move it to the side if you want to, but still it's quite brittle, so you have to be extra careful not to break this. I mounted the cassette deck mechanism back into its original cradle, but without connecting the play and record heads or anything else, so switches and such. Only the motor is connected to the power supply. So let's switch the recorder on, and you'll notice none of the lights come on, so that's still a problem we need to fix. That is, if the cassette deck will work. Alright, so this is the rewind button, so let's see if it will work. So this should start to turn clockwise. I don't know. There's quite a bit of slippage. But I think I see why. Some oil accidentally was sprayed on the little rubber wheel down there. So okay, let me clean that up and then give it another try. Alright, attempt number 2. Here we go. Yeah, great. The auto stop works perfectly as well, since there is no tape load on both spindles. The cassette deck detects that there is no traction, in fact, and therefore stops the rewind spindle automatically, in fact. So that is great. Now let's see if the fast forward still works. Oh, that's the play. Well, okay, the play works. Now let's do the fast forward. And you can see the little spindle there, the little lever going back and forth. That's the detect, to see if the tape is at the end. So, come on. Yeah, there you go. So as soon as this spindle stops, the cassette deck knows that it's at the end of the tape, and it will stop automatically. Alright, I let the cassette deck play for roughly, say, half an hour, and yeah, the sound is all over the place. I mean, it plays fast, it plays slow, it plays in between. Sometimes it speeds up, sometimes it slows down. So I'm beginning to think. So I measured the power going to the speed regulating board of the motor, and the power is spot on. So it should be 7 volts between the black and the red wire. Yeah, so 7 volts DC. And yeah, so the power supply is just fine, is perfect. So I'm beginning to think that there is a problem with the speed regulation, and I'll tell you why. I tried to change the speed of the motor with the potentiometer you see here, and absolutely nothing happens. I mean, the motor doesn't speed up, doesn't slow down, it just nothing really changes. Alright, some of the fog which was surrounding the mystery of the motor, which wasn't running anymore, I think has been lifted. On this little board, like I said a few minutes ago, is the speed regulation board, with which one can set the precise spinning speed of the motor, right? Now, you'll notice here this little connector here, this tiny Molex connector, which connects in fact to this one right here. And you'll see there's a red, a black, and an orange wire. Now if you look at the schematic, you'll see that the speed regulation board for the motor has in fact 3 connections. It has one here, which is ground, alright. It has one here, which runs through a switch and then to the motor, which comes from this bridge rectifier and should yield about 7.2 volts, unregulated. Okay, so this voltage is unregulated. And then there is a third line, which is this line here. And this line should be regulated, and it should be regulated to produce 20 volts. Alright? Now it turns out that this line and this line are respectively ground and or black and red. The black and red wire. Alright? This wire, on the other hand, is the orange wire, and with this one should carry 20 volts. Now, after doing a little bit of measuring and testing, it would seem that the power transistor, the original power transistor, which is in fact on the schematic, this one here, Q403, was in the end defective. At first glance, when measured, it seemed to look okay, but as soon as it would have to carry a certain amount of current, it would seem that it failed. The orange wire, which you see here, which carries the 20 volts, remember, you see here on the schematic, is not conducting anything, or barely. I mean, maybe something like 200 millivolts or something, not 20 volts. But, you know, I have to make sure that that was indeed part of the problem. So, what I did was, I connected up the speed regulation board of the servo motor you see here to the black and the red wire, which carry, remember, 7.2 volts or thereabouts. We'll see in a minute. I'm monitoring the output, and I'll simulate the 20 volts line you see here by attaching my variable power supply to a pseudo orange wire, and that way I'll be able to supply 20 volts but via my variable power supply. The ground of my variable power supply is connected to the same ground as the 7.2 volts. Alright, so the ground is common. Alright, so let's see. So the motor is there. Alright. In a second I'm going to switch on the cassette deck, and I set the fast forward button. So I pushed in the fast forward button. So theoretically, when I supply the 20 volts on top of the 7.2 volts which the tape deck supplies, the motor should start spinning. Okay, so first I'm going to switch it on, but without the 20 volts. Alright, the motor isn't spinning, as you can tell. Alright. The output of the black and red wire slowly creeps up to about 7 volts, maybe a little bit more. Alright? Remember, this voltage is unregulated. Okay, so now I switched on my power supply, my variable power supply. Yeah. And now we're going to touch the 20 volts, which is on this little orange wire here, to that center pin of the Molex connector. Alright? So I have to be a bit careful not to create a short. Can you see this? Yeah, I think you can see this. Okay, so there we go. You see? Now the motor is spinning. Now I release the 20 volts. It stops. I touch it again. The motor spins again. So, to my great annoyance, let's say, there is a problem still with the power supply of the cassette deck. Alright, so the power transistor on the right is the one that obviously failed in the power supply. This is a regular, I would say, NPN transistor. I looked up its specifications, and the closest thing to it that I have in my stash of components is a TIP-131C in this case. Now, this, in my opinion, will probably work, but this is total overkill. Alright, so this has about 3 times the capabilities of this one. So obviously this transistor here had failed in the past, and we don't know yet for what reason. It might be that the transistor was simply spent and broke, or there might have been a short of some sort. Either way, I had to replace this resistor here, the original one, because it overheated. Alright? So, to make sure that there is indeed no real problem inside the tape deck, what I did was I left the space for the transistor open, and I've mounted a sacrificial wire to the emitter copper trace of the PCB. So what I can actually do with that setup is I can eliminate the transistor temporarily from the PCB, and since this supplies the rest of the tape deck with 20 volts DC regulated, I can now pump in my own regulated 20 volts right here at the copper trace where the emitter was connected, and I can do that with my variable power supply you see over there. So that way I can test the tape deck and see whether there's a problem or not, and limit the amount of current that would go through it. You know, because my variable power supply has a current limiting setting as well. So yeah, what I'm going to try is to let the cassette deck run combined with my variable power supply, and then see if it works normally. After a couple of hours of searching and searching for what was causing all the mayhem on the main board of the Sony, so this is the main board in fact, I finally found which part was causing all the trouble, and it would seem it's this tiny little part here. This Zener diode, in fact, was causing all the trouble, and it's something like this. Alright, so I don't know precisely what the wattage of this Zener diode is. It has a code, I don't know if I can show you, but it has a code something like minus 20, I think. Yeah, minus 20, and then 66. R. Alright? Now, this is a 20 volts xenodiode, but I don't know what the wattage it is. What's the wattage it is rated for? Either way, this xenodiode was like a short circuit, and that was why R301 was so roasted. Okay. Alright, I replaced the light bulbs for the VU meters by LEDs. There you go. And I did the same thing for the record light or indicator. There you go. Obviously I replaced that by a red LED, not blue LEDs. But you know, everybody who watches my channel and knows me a little bit knows that I like blue LEDs for lighting panels and indicators and all that. So instead of filament light bulbs, from now on this cassette deck will go through life with LEDs. That's a nice upgrade. Alright, so here's a quick view of the mechanism while it's working. So fast forward. This is the stop button, by the way. Rewind, that's that button. And the play button. Although the weather is pretty cool today, it's sunny and dry, and I think I will give the frame, at least the wooden frame of the Sony, a layer of satin gloss lacquer just to protect it a little bit better. So what I'm going to do is I'm going to unmount the brackets, which are mounted top and bottom, and then I'm going to hang the frame up and give it a lacquer layer. And there you are. I sprayed the whole wooden frame of the Sony with a layer of satin lacquer, so which should give sort of a half matte finish, which it had originally, but with the added benefit that now the woodwork is protected. So I'm going to try to polish out a few of the larger scratches from the cassette door, which you see here. Okay, and you see some of the scratches on the plastic. And I bought recently some polishing compound, which I think might do the trick. I'm not sponsored by this product in any way, shape or form. It's just that I want to give it a try and see whether it helps to buff out, let's say, most of the scratches from polycarbonate plastic like this is. And here's the result after I'd say 15 to 20 minutes of buffing. Alright, so not perfect, but certainly a lot better than what it was before. And the largest scratch that was on the panel is practically gone. There's maybe the tiniest of remnant of it, but it's barely noticeable. Alright, the way to record a song on a cassette is that you engage pause first, then you press both play and record in, and you leave the pause on. And then you start the song like that, and you release pause. I'm recording it a little bit on the quiet side because it's already night and I don't want to wake up people, but let's push it to 6. Okay, let's push it up a bit more, say to 7. Even 8 on thereabouts. So notice that the volume buttons are also the input level buttons, okay, or sliders, with which you can admit more or less sound into the line input. So yeah, let's see, I'm not going to record or record the whole song. Yeah, I'm not going to record the whole song, but let's say another 30 seconds or so. Alright, spooling back. Okay, here we go. Alright, so it records and it plays back. Is the quality excellent? No, by no means. Most of all because this tape deck has been heavily used, and I would even say abused in its time. And the motor is a little bit tired, and probably the heads, the record and the playback heads, despite that they're saying it's super permalloy, yeah, the heads should be replaced, and the motor probably as well. But you know, considering the state it was in, I would say it performs reasonably well. But with this cassette deck be used by a hi-fi aficionado? No, not at all. It's in the state it is in. It's really not good enough for a hi-fi, high fidelity installation. Like I said, the motor needs to be replaced, and probably the record and the playback head as well. But I'm running out of time, and I ran out of money, at least for this project, so replacing the motor and both heads on the tape deck will be something for a follow-up episode. So either way, I hope you enjoyed watching this episode and me repairing and restoring a Sony TC-144 CS cassette deck from the 70s. Thanks for watching.